Welcome to the Deep Dive. We dig into your sources to uncover the most compelling insights. Today we're grappling with, well, a huge question that seems to be on everyone's mind. What exactly is true intelligence? And can artificial intelligence ever truly achieve it? We've looked into some fascinating perspectives, really, from two giants of science. First, there's Nobel laureate Sir Roger Penrose, who argues consciousness is, non-computable. And then the legendary physicist Richard Feynman, who gives a pretty stark view on how machines think, or maybe how they don't think compared to us.
Right. So our mission today really is to unpack these different viewpoints. We want to explore the fundamental differences between how humans understand things and how machines compute things. We'll look at AI's capabilities, its limitations too, and crucially, whether the word intelligence even fits what these powerful systems are doing. Get ready for some moments that might just, well, reframe how you think about AI.
Okay, let's get into it. So Roger Penrose kicks things off with a pretty bold claim right off the bat. He says the name artificial intelligence itself is wrong, misleading.
Yeah.
For him, it's just not intelligence. Why? Because it lacks consciousness.
And that's the key point, isn't it? How Penrose defines intelligence. It inherently involves consciousness. He's quite firm that current AI devices, well, they aren't conscious. And he doesn't think they will be unless, as he puts it, other ideas are brought in. His core argument really boils down to this: these systems only operate on computable notions.
Computable notions. What does that mean exactly in simple terms?
Basically, things that can be broken down into a step-by-step procedure, an algorithm, like a computer program following instructions very precisely. There's no ambiguity, no intuition involved. It's all rules.
Got it. And this is where it gets really interesting, because he ties this directly to a mind-bending mathematical concept, Gödel's theorem. He mentioned learning about it back when he was a graduate student, alongside things like general relativity.
Yeah, imagine that cohort. He calls Gödel's theorem stunning. And for him, it's stunning because it shows that understanding, human understanding, kind of transcends just using rules.
Transcends the rules. How?
Well, the gist is that Gödel constructed this mathematical statement, a statement that basically says about itself, I cannot be proved by these rules, meaning the rules of the formal system it's part of.
Okay. So a statement that says it's unprovable by the system's own rules.
Exactly. And here's the clever part, according to Penrose. If you believe your system's rules only produce truths, then this Gödel statement, which claims it can't be proved by those rules, well, it must itself be true.
I see. So it's true, but unprovable within the system.
Precisely. And for Penrose, that's the kicker. To know it's true, you have to step outside the system. You have to understand why the rules give you truths in the first place. You need that insight, that understanding.
Which he connects to consciousness.
Right. He argues that a purely computational system and AI just following rules can't make that leap. It's stuck within the rules. But we, with consciousness, can see the bigger picture and grasp that unprovable truth.
So bringing this back to AI, Penrose basically argues that AI doesn't know what it's doing. It might string words together based on patterns, speaking from experiences, as he puts it, but it lacks genuine understanding.
He thinks people have kind of lost the thread because they're so impressed by the sheer power of computing. They're confusing that computational ability with real understanding.
So if understanding needs consciousness to go beyond the rules, and AI is just computation,
then for Penrose, AI is fundamentally missing that crucial ingredient. He mentions the Turing test, the test for whether a machine can seem human.
Right.
But even if it passes, for him, it's still just missing something essential. He's not saying AI isn't useful. Its computational power is amazing for things like analyzing huge data sets.
Sure.
But he really stresses understanding is different from computing. They're just not the same thing in his view.
Okay. That's a really strong philosophical stance. Now let's shift gears a bit. Let's bring in Richard Feynman, another legendary mind, tackling a similar question, but, well, from a really different angle. Can machines think like humans?
Yeah.
Or even be more intelligent?
Feynman's answer to the think like human beings part is pretty clear. No.
A flat no.
Pretty much. He argues, quite practically, that we design machines for efficiency using totally different materials than, brains. His analogy is great. Airplanes don't fly by flapping wings like birds.
Right. They use jets or propellers, different mechanism, same goal.
Exactly. So machines won't do arithmetic the same way as we do arithmetic. They'll do it better, faster, sure, but differently. Fundamentally differently.
He had that brilliant example about remembering numbers, didn't he?
Oh, yeah.
He challenges you, the listener. Try recalling, say, 20 or 30 numbers then recall them in reverse order, then maybe every other one in reverse order.
Yeah, good luck with that.
Exactly. My brain melts after maybe 7 or 8. But then he points out a computer handles 50,000 numbers easily. Perfect recall, no forgetting.
It really highlights the raw processing power difference, doesn't it? The sheer memory capacity, the speed, doing complex calculations without errors.
So for tasks that rely purely on that.
Well, like weather prediction, which he mentions, that involves looking at masses of data, running complex calculations over and over. Feynman was pretty convinced machines would eventually just be faster, more effective, more accurate than humans at that kind of thing.
Okay, so computers win on raw calculation and memory. But Feynman also points out areas where humans really excel, right? Like complex pattern recognition.
Absolutely crucial point. He talks about recognizing a friend. You don't analyze pixels, you recognize them by particular wiggle, he says, or a hair flip.
Yeah, you just know it's them.
Right.
Right.
And that's incredibly hard for machines. Think about all the variations, the lighting changes, the distance. They might be wearing sunglasses.
Or even just like dirt on a fingerprint image he mentioned.
Exactly. For a machine to have a definite procedure, a fixed set of rules to account for every possible variable, like the angle of the finger or if there's a wart on the thumb, it just becomes, in his words, so complicated and elaborate, it's utterly impractical.
But a human.
A human does it in a snap, instantly. Our pattern recognition is flexible, adaptable in a way that rule-based systems struggle with.
Okay, so calculation. Machine advantage.
Yeah.
Complex, fuzzy pattern recognition. Human advantage. What about discovering new ideas? Can computers do that?
Feynman says, interestingly, yes, if the problem of finding that new idea or maybe a mathematical proof can be turned into a definite procedure.
Back to the procedures again.
Sort of, but he gives this fascinating example of a program written by a guy named Linnet, I think. It used something called heuristics.
Heuristics, those are like rules of thumb, smart shortcuts.
Exactly. Not rigid rules, but more like guidelines or educated guesses to narrow down the search. Instead of checking every single possibility, which would take forever, a heuristic helps the machine focus on promising paths, like in chess, maybe try moves near the center of the board first.
Makes sense.
So this program was for some kind of naval battle simulation game, and it actually won championships.
Wow, how?
Well, the first time it designed this one massive super battleship, something no human player had thought of, it just dominated. Then the game rules changed to limit ship size. So what did the program do? It designed a fleet of like 100,000 tiny boats. Again, something humans hadn't considered. It just swarmed the enemy.
That's creative in a way.
It is. And what's really remarkable, Feynman points out, is that the machine actually learned by itself which heuristics were working best. It adjusted its own strategies based on success.
So it was learning.
In a sense, yes. But Feynman also found these funny bugs or quirks in the system, and he thought these revealed something interesting, maybe a kind of intelligence in their crazy ways of avoiding labor.
Avoiding labor, like being lazy.
Kind of, like one heuristic basically just told the program, pay no attention to that part of the problem, just to save processing time. And sometimes it worked.
Cutting corners.
Right. Or another one was accidentally programmed to always assign credit to heuristic 693, no matter what actually worked. So heuristic 693 looked incredibly effective, even if it wasn't doing anything.
That's hilarious. But he saw intelligence in that.
He suggested these kinds of things, these necessary weaknesses of intelligent systems, these slightly unpredictable, maybe even buggy behaviors, might mean we're actually getting close to intelligent machines. It's not perfect logical computation, but something messier, more adaptive, maybe.
Okay, so let's try and connect these dots. We've got Penrose arguing really strongly that true intelligence needs consciousness. It needs that ability to understand, to go beyond the rules, which he thinks AI lacks.
Right, a deep philosophical requirement.
And then we have Feynman. He acknowledges machines are computationally superior in many ways. He even sees them learning via heuristics and showing these quirky, intelligent behaviors. But he also stresses how differently they operate. They don't think or recognize patterns like we do.
Yeah, it seems both agree AI doesn't replicate human intelligence, but for, well, quite different reasons. Penrose focuses on that qualitative gap, the lack of conscious understanding. Feynman focuses more on the practical, functional differences stemming from how they're designed and what they're good at.
It does raise that big question, doesn't it? Do we actually need machines to think exactly like us? Or is it enough if they just accomplish tasks we consider intelligent, even if they do it in a completely alien way?
Feynman definitely seems to lean towards the latter, doesn't he? He even kind of implies our way of doing arithmetic is slow, cumbersome, and confused compared to a machine's efficiency.
Yeah, he wasn't sentimental about human methods there.
Not at all. It's almost like Penrose is looking at the soul of intelligence, the subjective experience of understanding,
Hmm.
while Feynman is looking at the output, the results, the capabilities, the problem-solving power, regardless of the internal process.
Because maybe they aren't entirely contradictory, just
Yeah.
focused on different facets of this really complex thing we call intelligence.
That seems like a fair way to put it. It certainly shows the conversation is much, much richer than just asking, is AI smart yet?
Absolutely.
hmm
This whole deep dive really forces you to question your own definitions, doesn't it?
Yeah.
What is understanding? What is consciousness? What does it actually mean to think?
I think maybe the biggest aha moment here isn't necessarily about AI becoming human-like. Maybe it's about really appreciating the different kinds of strengths that both humans and these artificial systems have.
Yeah, recognizing their different tools, perhaps.
Yeah.
Good for different things.
Exactly. Understanding those distinctions helps us see where each can contribute best, and maybe helps us understand the limits of understanding itself, both ours and the machines.
So after digging into Penrose and Feynman, what really stands out to you listening right now? Does that spark of genuine intelligence absolutely require consciousness that Penrose insists on? Or is it more about what Feynman highlights, just getting the job done effectively, performing complex tasks, even if the thinking behind it is totally different from ours?
And here's a final thought to chew on. What does it imply for us, for human ingenuity, for how we see ourselves, if machines keep demonstrating what looks like intelligence, maybe through those crazy ways of avoiding labor Feynman talked about, without ever needing to understand in that deep, conscious way Penrose describes? How does that change our place in the world?